Hi, welcome to Blender 4.5 course. In this course, we'll start Blender 4.5 LTS version from scratch. And this course is very useful for who wants to begin Blender and also the users they have already working with Blender and wanna learn Blender 4.5. In this course, I'll cover modeling, animation, material and shader design, UV mapping, rendering, lighting, compositing, and so on, completely from scratch. I'll upload the full course on the blackcave.com store and you can access to the full course on this website. Also, it has bonus chapters. Also, you can get access to other courses related to the 3D rendering, 3D modeling, and also game development. You can get access to many tutorials and extra chapters, advanced chapters of this course. Also, at the final, you can get a certificate and add it to your resume. Also, the link is in the description. Right, let's start. The Blender 4.5 LTS or long time support version is the most stable version of this Blender. So let's start with the user interface. We have the file, edit, render, window, and help menus, which we can create and add a new Blender file here. General is the general purpose project, 2D animation, which it will activate, 2D painting for us, and some features related to the 2D sculpting, which it will activate, the high poly sculpting like ZBrush and Rhinoceros software, if you know about them, VFX, which is good for creating some complicated VFX systems and particle systems. We will work with them later in the future videos, and video editing, which it provides some basic properties and tools to edit your video. You can open a scene and another Blender file. You can save or save as your current Blender project and import 3D models and other assets to your project and export your models to another file except the Blender, and you can create the project. If you press the save as, we can save your project and the file type is a .blend. I need to say I'll ignore some options and tools and I'll explain it gradually in the future videos, but I focus on basic and most important menus and parts at the first. In the edit menu, we can access to the undo and redo. We can change the history with these two options. We can press Ctrl Z for undo, and redo is Shift Ctrl Z. In some other software, we can press Ctrl Y to redo, but here we have Shift Ctrl Z. Here we can search for a specific menu if we can't find it, and this is very useful. Also, we can rename a selected object in the scene, and here we can access to some settings related to the Blender. For example, we can change the user interface, viewports, manage the add-ons and plugins, and import everything we want. We can access to the themes and modify them. We can change the keyboard settings, especially if you have minimal keyboards. You can change some keys. For example, if you want to switch the camera, you need to press the 0 key on the numpad. Some keyboards doesn't have numpad and you need to change it. For example, my keyboard doesn't have numpad and I need to change the camera option to, for example, Control Shift and 0. I'll do it later. Here in the system we can change the settings related to the render engine. For example, we can select one of these options based on the GPU. If you have NVIDIA GPUs, you can select CUDA. If you have, I think, AMD, you need to use this HIP, and so on. Alright, in the render section, we can render an animation or image, a single shot, single frame from our scene. We can also render an audio. We can view the render. If we render something and then close the rendering window, we can open the render view again using this button or animation. In a window, we can create a new window and place it here, and the main window, which is this, we can place it here, and we have a split screen capability. Or if we have other monitors or a white monitor, we can add many windows, infinite number of windows, as much as we want. For example, if we select new window, here we have a simple window, and here, which I'll explain in detail later, we can switch to other environments. Or with this, we can add another window similar to this main window. Here we can change the workspace, go to the next workspace, previous workspace, and even we can save the workspace. Here in the help, we can access the manuals, tutorials, and support team. Using these fields, these panels, we can change the entire Blender environment. For example, here we can access to the default workspace and default environment of the Blender. We can go to the modeling section. We have advanced tools for modeling. In the sculpting section, we can easily access the sculpting capabilities, just like ZBrush software, for example. Here we can access to the UV editing. This is related to the texturing. If you don't know about UV mapping and UV editing, I'll explain it later. As I said, it's a from scratch course, and it's useful for beginners and also who is familiar with Blender. In the texture paint, we can paint on a model easily and create our texture. In the shading, we can define our shaders and materials to add effect to our models and apply the textures and so on. This is very useful, and I'll focus on it in depth later. In the animation, it's obvious, we can animate our models and our entities in this 3D view. We have a timeline, which is useful for animation. In rendering, we can access to the renders. Here, if we render an image, we can access to the rendered image here. In the compositing, we can add many features to the result, to the final render. For example, adding more realism, adding light shafts, adding black outlines, and so on. Here in the geometry nodes, we can add logic to finally add some automation to our workflow. For example, adding 100 cubes to the scene randomly, positioned randomly in the scene, and some other automation systems. In this scripting, we can write scripts in Python language to add automation systems just like geometry nodes, but we have extra features using Python. Alright, let's get back to the layout, and here we have a 3D view. In the 3D view, we can rotate the camera using middle mouse button easily. We can press the shift and middle mouse button to pan the camera. We can press the control and middle mouse button to zoom in and zoom out, and also you can scroll. Also, you can select everything you want in the scene, cube, this light and this camera, and you can see a list of your objects and entities in the scene using this window. I'll explain later what a collection is, scene collection and collection, but you can see the entities in the scene here. For example, camera, cube, and light. You can select them here or here. Also in this list, which is very important, you can access to many features. For example, selecting the render engine, selecting the exporting format, changing the model and entities attributes, and so on. Select this cube and you can see some features changed, or this. Here we have material. This is related to the 3D model, but for the light we don't have material section. I'll deep dive in to this section later. Here at the bottom we have a timeline which is related to the animation, and we can close it, right click and close the area if you don't want it. I'll explain it in the animation section, and I'll explain what the timeline is. Also, we have some options here that we can move, rotate and scale our objects and modify them. And also in the tab here we have access to some useful features. For example, we can change the workspace and environment here. For example, let's switch to compositing. Without this button we can easily choose compositor here, and we have access to the compositor window, and we can get back to the 3D viewport here. Here we can change the view and viewport. We can select a specific object or all the objects. You can add objects here and scene entities, and we can do some operations on the objects in the scene using this menu. I'll explain this step in detail later based on our needs. Also, we have a hidden menu which we can press the N key and we can access to some other features. Features related to the selected item in the scene, or some tools, and some properties related to the viewport. This vision and this camera, I can see the scene through it, is the viewport. And you can press the N key to hide this menu again. Alright, this is the Blender UI and the basics related to the environment of the Blender. In the next part, I'll focus on more details, for example, rotating, moving, and scaling objects in the scene and modifying them. Welcome to part 2 of the Blender 4.5 course. You already know about the Blender interface and basics and how to move and rotate the viewport. I explained them in the previous part, in the part 1. Now let's explain more details on the viewport. As I said, these objects are listed here in the hierarchy list. We can say this is hierarchy. Simply, we can select them, and also the object we select here will be selected in the viewport as well, and vice versa. Every object in the scene has a specific entity, a specific property. For example, 3D models provide various shapes, but basically they are 3D model type. But this is a light, the type of light. We have many shapes of light, but the type of it is light, and this is camera. And the type of camera, we can change the camera, the lens, and other properties, but this is basically a camera. So we have many types of objects in the Blender that we can use it in the scene, and I'll explain how to add them. First, let's explain how can move and rotate the objects, scale the objects, and so on. Here, we can select the cube. This is cube. And we can press this button, which is the move button, and move it along the x-axis. The red direction is the x-axis. This is y-axis. We can see these directions by their name here. The green line is the y-axis, and the z-axis, which is the up direction, is the blue. And easily we can move it in the x-axis, y, and by pressing the left click. And also we can press the center of them and move it in 3 directions. All right, how to rotate the object? We can select the rotate tool and rotate in these directions, that is y, this y, z, and x. Also, we can rotate the object by pressing the center of the all directions and rotate along the all directions. Also, we can use the move and rotate for this objects, light, and also the camera. I'll explain the light and camera capabilities and applications later, but I focus on the move and rotation tools for now. And the last tool is the scaling tool. You can select an object and scale it along the x-axis, y-axis, and z-axis. And also we can press the center here and scale it up or down along all directions. Alright, but we can't scale this light because this light is not a 3D shape, a 3D object, and the scale tool is useful for 3D objects. We can scale a 3D object in any axis we want, but a light is just a sign, it's just a icon, and we can't scale it up or scale it down. But for some specific objects, for example camera, we can scale it up or down. It will affect on the lens and other properties of the camera. Alright, we have other ways to move and rotate and scale the objects. We can press the shift and a space and access to a menu just like this menu. Here we can press the move and here move the object, or shift the space and rotate, shift the space and scale. And also we have a transform tool, which we have transform here as well. We can access to rotate, move, and scale at the same time, and we have all the signs and icons of moving, rotating, and scaling the object. Also, the last tool I want to introduce is the measure tool, which we can select it from here. We can measure something. For example, left click here and drag. We can get the length of here, the starting point here, and until the end point. But this is not good. I wanted to measure the cube, the bottom part of the cube. We can do it in detail later, but this is the measurement tool. Also, we have keyboard shortcuts for transformation tools. We can press the G button on the keyboard and move the cube easily. If we press the left click, we can place the cube there. And also, if you press G and press right click, we can cancel the transformation and it will get back to the previous position. Also, we can press G and we have a key guide on the bottom of the Blender. As you can see, if we press the X key, we can move the cube along the x-axis. If we press the Y key, we can move along the y-axis, and if we press the Z, we can move along the z-axis. If we press R, we can rotate the object in all directions, but we have the same structure just like movement tool. We can press the X to move along the x-axis, Y, and Z. And also we have the S key for the scaling tool. If we press the X, we have this, Y, and Z. Alright, these are the transformation tools. Now let's focus on adding objects and entities to the scene. For instance, 3D models, lights, cameras, and so on. How to do it? We can press the add here or press the shift and A. Many Blender users, and I can say all the Blender users, use the shift and A, the keyboard shortcut. Here we have lists of entities that we can add to the Blender viewport. Here we can add mesh 3D models. We have many types of 3D models I'll add later, and I'll explain most important entities that we will use. Curve is a 2D object that makes a curve with custom points, for example, for hairs and so on. Text is obvious, is a text entity. Armature is useful for characters, which they provide skeleton, that I'll explain what a skeleton is in future videos. We have light year, we have 4 types of light year, and we have the camera. Also, we have the audio system. I'll add all of these entities one by one. Let's focus on the mesh. The first one is the plane. Plane is a simple object that is useful for grounds, walls, and flat surfaces. I said it's simple. Simple means it has few points or vertices that I'll explain what a vertex is. That is very light to compute. For instance, cube is more complicated than this plane. The next object is cube, and it is similar to this cube. We don't need it. We can press the delete button on the keyboard. And we have the circle. Here, circle is a kind of 2D object, not a 3D, because just we have a ring here. It is useful to create some objects. It's a basic for creating some 3D objects. It's not a 3D itself. We have UV sphere. UV sphere is a kind of complex object. We have many points and vertices on this object. And the other hand, we have icosphere. Icosphere has a different structure, but it is lighter than this sphere. As you can see, these areas are the points or vertices of this sphere, and these areas are the vertices for this sphere. So as you can see, we have many points and vertices here, and this is more complicated than this sphere. The next object is cylinder, and it's a cylinder, and these points here are the vertices of the cylinder. It is not too complicated, but we can modify it, modify all of these 3D shapes later and make them more complicated or make them lighter by increasing and decreasing the vertices and the points on the object. Press the shift A, and here we can access to the cone mesh. Here this is look like this object, this cylinder, and the number of vertices and the number of points are kind of similar to this cylinder. Here, as you can see, these areas are vertices, and the last object is truce. Here can access to a more complicated object that is not very useful for our models. These, let's delete it. These 3D objects here are primitive shapes that many 3D models will be created with these objects. Also, we have some other complicated objects. For example, a monkey that is very useful to test the lights and shaders, not for complicated modeling. Alright, here we have light and camera and audio, but I don't want to add them to the viewport because adding lights doesn't affect on the scene without going to the render view. I didn't explain the rendering, I will explain it, and after that I'll focus on the lights because it depends on the rendering section and also the camera related to the rendering. So I need to explain about rendering and the next part, then I'll focus on the light and camera. Welcome to the part 3 of the Blender 4.5 course. In this part we're going to work on the rendering section. And rendering in Blender has two main sections. One is the material view that we assign a material or coloring property and textures to each 3D model, and we can see the preview of the color and textures and finally the material of the 3D model. And the next section is the final render that we can see the lighting, the shadows, the materials, and post-processing in the viewport, and also can render a final image or animation. If we want to explain about other phases, we can say we have the solid view. This is a solid view. We can see all the 3D models in a white color or kind of white color, and we can't see any shadow or lighting effect. Also, we have another view which we can select it from here. Here, this is the wireframe view. We can see the edges and vertices and points of every object. Here you can see the complexity of the UV sphere and also this and this. And as I said in the previous part, the plane object is the lightest 3D model in the Blender and actually all 3D software. This is the material view that I explained. And as you can see, all the 3D objects are white because we didn't actually assign material and texture and no color to the 3D objects. Also, we can see a default shadow. This slide, as you can see, we move it and we can't see its effect on this shadow. We can see the effect of this light and other lights only in the final render. And here, if I move the light, this is a point light and represent a light just like a bulb. And you can see the light position and the shadows are changing. And this is the final render. Also, we can press the Z key on the keyboard and switch between all these status. We have in the rendered view, we can go to the solid, we can go to the material preview, and we can go to the wireframe. Now let's talk about the render engine. Many 3D software offers just one render engine. For example, Maya offers Arnold 3D engine. Cinema 4D offers Octane render engine. But in Blender, we have two 3D engines. Here, in this menu, we can access to the render engines and switch between them. The default one is the Eevee render engine, which we have access to the improved version of Eevee engine after Blender 4.2. Actually, this is the Eevee Next, and removed the vanilla and the traditional Eevee engine in the Blender 4.2 and renamed the Eevee Next to Eevee. And now this is the upgraded and improved version of the Eevee and this is the real-time render engine. And in the other hand, we have Cycles. Cycles is the offline 3D engine, which means for rendering a single frame, we need to wait, and it takes a while to render based on the render quality and the 3D objects in the scene and the complexity of the scene and lights and shadows. But in the real-time 3D engine, we can see everything instantly, just like game engines, for instance, Unity, Unreal Engine, and so on. We can see everything in real time. But the quality is not same as the Cycles. Cycles is useful for cinematic projects, for movies, for top quality animations. But Eevee is sufficient for a quality near to the video games. Now let's switch to the Cycles, but let me give you this advice. First go to the solid mode and quit from rendered view and then switch. This is better because sometimes switching to the Cycles in render view results crashing the Blender, and sometimes you can't open the Blender again. You need to restart your PC because the background process of the Blender is still active, and you need to find it in Task Manager and end it, and finding add is hard and takes a while, so restarting your PC is better choice. Here, let's go to the render view using the Z key. Here, as you can see, rendering a single frame takes a while. You can see a sample count here. Sample count means the quality of the render, and as you can see, we have some noise here, and higher number of samples destroys these noise. But we can make it faster, make the cycles faster if we change the device to the GPU, not CPU, because GPU has many threads and cores, and it is very useful for image processing. The rendering process is a kind of image processing, and GPU is very fast for this job. But I need to say that NVIDIA GPUs are better and give you a better performance for GPU rendering. You can use AMD or Intel GPUs to render the scene, but NVIDIA is faster because of CUDA cores. You need to go to the edit menu and go to the preferences. Here, if you have NVIDIA GPU, you can select the CUDA, and if you have an AMD GPU, you need to select the HIP or HIP. Right, I selected CUDA, but I need to switch to GPU compute. Here, as you can see, the samples much faster. Let's compare the cycles with Eevee. I switched to Eevee, but I don't quit from render view. And as you can see, we have big differences, but we can improve the Eevee. I'll explain it later. But for now, let's focus on the Cycles. Cycles has two sections, viewport and render. We can specify the attributes for the final render, and we see those attributes only in the viewport mode, but in the render, we can see these attributes on the final render, which we can select this menu and press the render image or press the render animation and go to the rendering section, and we can see the final render here. This section is related to this view. Here in the viewport, the default value for the max samples set to 1024. It means the samples need to be reach the max sample, but as you can see in the 50 it stops and says rendering done. So why? Because an option called noise threshold is activated. Noise threshold means we have rational count of noise, and if we reach a rational count, we don't continue the rendering process. If we disable this option, as you can see, it will grow up to 1020 4. And as you can see, we have a softer result and noise is disappearing. Also, we can activate an option called denoiser, and as you can see, the rendering process is so slower now, but we have a stable and good result at 20 or 30 samples, and we don't have any noise here. Let's see. As you can see, we have 5 samples and we don't have any noise here. Denoiser should be activated in the final render. It is better, but here we need to deactivate it because it will make the process very slower, and we don't want it for the viewport, because actually a preview final render is sufficient for the viewport rendering. For the final render, the max sample is very larger than this value. We can specify a value based on our needs. Mostly I use 500 or 600 for my personal renders and use denoiser for the final render. Also in denoiser, these two denoiser are similar. We have two options, optics and open image denoise. This option is better. We can also balance the other attributes, for example, to final quality of the denoiser. Let's check here and change the quality, for example, to fast. And here, as you can see, the render process is much faster. Let's switch to high, and as you can see, this is very slow. Now, as you can see, the differences between cycles and Eevee, especially in the shadowed areas. Can we make the Eevee better and near to the cycles? Yes, we can. In the new generation of Eevee engine, we have a capability called ray tracing. This is a software ray tracing, not like hardware ray tracing provides in most video games. This is software ray tracing. It means if you don't have GPU on your PC, it works. If you have a cheap GPU on your PC which doesn't have a ray tracing system, doesn't matter, it works. Just turn on the ray tracing, and as you can see, the result is very better in the shadowed areas. Let's see, and this is the final result. And let's switch to cycles and see the result. It's near to the cycles, but the quality is still lower, but it's worth it because we can see the result in real time and we have a almost good result. We can modify the attributes and properties and balance them in the resolution. 1 is the best resolution and this 16 is the lowest resolution. In the screen tracing, we can change the properties, for example, precision, and increase the precision of the ray tracing process, also the thickness of it. And here we have a description, and it says surface thickness used to detect intersection when using screen tracing. In many cases, I use a high value, something like 1 or 2. Let's change it to 2, but changing it is not very useful here because our scene is not too complicated. But let's change it to 4. And here, as you can see, let's switch back to the 0.2. And here we have darker areas, and in the 4 value, we don't have darker area. Here we have the same process here. And actually with the high values, we have more indirect lighting in the scene. I will talk about the indirect lighting and the techniques of it in the future videos. The denoising section is not similar to the cycles. If we disable it, as you can see, we don't have a very big difference. It's not too obvious. And also in the fast GI or global illumination or indirect lighting, we have several options related to the indirect lighting that, as I said, I will talk about it later. It's complicated to talk about in one video. we need to work on it in the future video. Alright, in the next chapter I will focus on the lights and cameras because you are familiar with the rendering now and we're ready to work with lights and some advanced stuffs. Welcome to part 4 of Blender 4.5 version. In this video, we'll deep dive into the lighting. You already know about the rendering and the render engines in the Blender, and we are ready to work with lighting. Here we have a scene. I didn't want to work with a simple scene with just a cube and primitive shapes. Here, this is my scene, and alright. I don't have any light in the scene. Let's see, press the Z key, go to the render mode. As you can see, I don't have any light. This one you can see is the emissive material. I'll explain it in the material design section later. This is not light. Actually, this is a fake light, and we don't have any light in the scene. Let me explain something. I don't want this grid, and I can't see my scene clearly because of this. I can't disable it using the button here. But if I press this, all of the UIs in the scene will be separate. And I need to press this button and disable the floor. Floor is a grid in the scene. Also, I can remove these lines, these axes, using these two buttons. I can enable the X, Y, Z axes, and I can disable them. Also, I can disable other UIs in the scene. I'll explain this section later in detail, but for instance, let's enable this. As you can see, the points and the vertices of every object now is visible. And you can work with the UI and the Blender viewport elements here. Right now, let's work with the lights. Press Shift A, and in the light menu, first let's add a point light. Point light is look like a bulb, and you can see the range of its brightness is everywhere, and it's a light broadcaster, light emitter, and we don't have any range or shape for the light. Moving it will affect on the lighting, but rotating it, press Shift space and rotate, doesn't affect anything, or scaling it either. And we can move it and wherever we need, for example, here or here. I'm using Eevee Engine, and this scene is real time. Alright, now I can navigate to the light attribute, this menu, and these sections are the attributes in the Blender, not just related to the selected object. For example, here it's general rendering settings and not related to the object. But here this is the object. For example, if I select this, I don't have any light icon here because this is not light, it's the floor. I need to go to the light section, and here we have the properties and attributes of the light, selected light. The first one is the temperature, and I can make the light warmer or cooler. Here, let's increase it and see the effect of the light here. As you can see, it's colder. And if I decrease it, as you can see, now it's warmer. Also, I can change the tint and change every color I want, but it's different from this option. If I disable this, instead of tint, I have a color attribute, and I can directly change the color, and I can't affect the color by temperature as well. Here we have a tint, and also I can multiply the temperature by the tint. Let's use the temperature and decrease this value. Here, this color is good. Here I have the power, and I need to increase it. Okay, and here I need to decrease the temperature a little. Okay, good. Also, I can increase the exposure. Exposure is a value that multiplies by the power and increases the power. I don't need to increase it for now. Also, the normalize will add a range to the light. For example, if I deselected, as you can see, my light doesn't have any smooth range, and actually it's not pretty for this scene. And normalize can limit the range of the light and make it smooth. Alright, radius is the most important part because balancing it can make the scene more realistic. Let's see this shadow. As you can see, this shadow is too hard and not good. I can make it softer using the radius and make sure the soft fall off is activated. Let's increase the radius, and as you can see, the shadow is so smooth. And let's back to the 0 value, and now as you can see, this value is more realistic. Let's see here and compare it with the real world. Real world lighting is not look like this result. This is better and more near to the real world. Right here, this value works. Right here we have the shadow options. I will talk about the jitter. Actually, all of the attributes here related to a capability called jitter. It's related to the advanced lighting, and I will talk about it later. Lighting techniques, for example, jitter and other advanced techniques need a separate video, and I'll talk about it later. Alright, the rest of the attributes are not as important as the others, and I will ignore it. Let's increase the temperature. Right, good. And now let's duplicate the light. We can press the Shift D to duplicate the light, or we can press the Alt D. But Alt D, as you can see, we have another light. But if I change the attributes of this light will be changed as well. And they are related to each other. But using the Shift D, we have two independent lights. Here, this is the light, and Shift D, here is the other one. Okay, let's add the second light, the sunlight. And its position is not important because sun is everywhere. This light is dependent on direction. Here, as you can see, direction of the sun is button, and this line, this yellow line, means button. We can press the Shift space and rotate the sun. I will do it in an exterior scene as well later, but now we have the scene and I need to work on it. And as you can see, the sun direction is changing, and we can see the direction using this yellow line. In the light section and the light attributes, I can modify the properties. Here we have the temperature, just like these lights. Here, select temperature and decrease it. Sunlight is warm. Alright. Now let's, I don't want to change the tint. Here, let's increase the strength. Its strength is equal to the power, just like point lights. And this is good. Alright, Here we can increase the exposure. As I said, exposure is a multiplier that will multiplies by the strength. And as you can see, the house environment is getting brighter. Not just the areas we have the direct light. Here we have brightness. It is indirect lighting, and I will talk about later. It's an advanced property in the Blender, and we have the normalize just like the point light. Alright, using angle, we can make the shadows smoother, just like radius in point lights. Here, if I increase the angle, as you can see, we have a softer shadow. And if I decrease it, let's get closer. As you can see, we have a very hard shadow. The higher value is better for a rainy weather, or if we have fog or mist in the scene, a higher value is better. But if the weather is sunny and there are no clouds in the sky, low value works. And in the shadow we have the jitter option, and as I said, I will explain it later. Alright, this is sunlight, and we will keep it, and let's introduce the next light, the spotlight. Spotlight is look like a flashlight or projector. Here, let's move it here using the G key. And as you can see, it's just like a cone mesh, and it has a range. It's the range of it, and we can rotate it, move it, and we can scale it using the S key to increase the range. And based on its shape, the light will start in a small range and it will increase. Right, let's scale it down. We can change the range using the light attributes as well, not only the S key right here. Here we have the temperature, color. For this light, let's change the color and don't use the temperature. For example, this color. And we need to increase the power. As you can see, we have a light effect here, and the power is too high. Let's increase the exposure instead of it. Alright, this is very good. Let's rotate it and see what happens. And if I press S to scale it up, we don't have any changes because our environment is small and this size is sufficient. You already know about the normalize. Radius is related to the soft shadows, and here we can increase it, and you know about it. But here we have the beam shape. Beam shape is related to this cone shape, and here with the size we can increase the max size, maximum size, and the bottom of the cone shape. And also blend will smooth this circle, and here higher values give you a smoother circle effect. And using this button you can see the cone shape and its effect on the scene. Alright, this is the spotlight, and it is good for projectors, for flashlights, and so on. Right, let's move it and work with the last light. Press Shift A and light, and here we have the area light. Area light is kind of look like the spotlight, and instead of a cone shape we have a square shape, and it will support a square area. This light is very useful for representation and lighting a character or a object that we want to focus on that object specifically, not an environment. But some lights look like this shape. Here, as you can see, the direction of the light is bottom, and we can rotate it, we can scale it, and here we can change the attribute and the light settings. We have the temperature just like before. the white color is good, or let's select a green color, it's better. And as you can see, we have a tiny effect, and we can increase it by increasing the power. Area light will affect on this range, not up. And here we can increase the exposure, and as you can see, it says square. And also we can change the entire shape. It's square, we can change it to rectangle. With this shape, we can change the X size, X direction, and Y direction separately, but square just has size, and both the X and Y will increase with each other. Also, we can change the shape to disc. It's a circle, and we have the size just like square, or we can select the ellipse. Ellipse is a disc, but we can change the X and Y separately. Area light is a simple light, and it's useful for representing a model. But we have something here. If we want to make the shadows smoother in this light, we had the radius for the point light and the spotlight. We had angle for the sunlight, but for the area light, we need to increase its size using the S key or using this attribute. And by increasing its size, its shadow gets smoother. Alright, these are the physical lights. Physical lights means it will work with algorithms and some complicated calculations written by Blender. And they are so heavy to compute. But we have another light in Blender. Let's delete these lights or disable this icon, and now we can't see them. We have another lighting system called HDR. It's not physical, it doesn't have a complicated calculation. It will use a texture or an image to provide lighting. So how to use it? We need to extend a window, or also we can add a new window in Blender. Just place your cursor in a corner of one of the windows, and here when you have a plus button, plus like button, you need to left click and drag, and now we have another window, or right click and close the window using the close area. Here in this window, I need to press this button and change the environment. I need to go to the shader editor. I didn't explain it, but I just want to work with HDR for now. You need to go from object to world. I will explain the shader editor in detail later. Here we have two nodes. Blender is node based. For example, if you want to create materials, post effects, composite your final render, lighting, and other works, you need to use nodes. Nodes are some attributes that provide a value to you, and you need to connect it to the result. Each node has a single input or several inputs and one or several outputs, and do some calculations for you. I'll explain it in detail later. Here we have two nodes. The first one is the environment lighting, and the second one is the environment result. Here, this one, we can move it and connect it, and the background means the scene color, connected to the surface. Surface is the lighting result. If I press the control and right click and disconnect this connection, as you can see, we don't have any scene lighting here. As you can see, the previous one provides a basic color, but here we don't have any color. Here we can change the scene color, for example, a yellow color, and here it will make it shine. And here we can increase the strength. And as you can see, we have a global lighting, and it's not heavy to compute. But instead of a yellow color, I want to connect a texture or an image to the color input. We can connect anything to the inputs, or we can change them by the field. But for the color, if we want to connect a texture, we can't assign the texture with this field. All right, we need another node that we can press Shift A to add a node. We have a lot of nodes that each one provides a specific attribute and property. Here we need to go to the texture menu and add the environment texture. And here we need to press the open button to open a texture. All right, here I have a lot of HDRI textures. They are, as I said, 360 images, and you can download many HDRIs from polyhaven.com. All of the HDRIs here I have. For example, these are my 8K HDRIs I've downloaded from this website. They are free and you can download many environments you want. Based on the image you will select, the lighting and the environment's color will be changed. And you need to use an image based on your needs. For example, if your environment is a kind of jungle, you can select this HDRI or this. If your environment is a kind of desert, you can select this. Let's select, for example, this. I need to say sorry about the double HDRIs. I have a small issue on my PC. Excuse me for it. All right, select this. The file type is EXR or HDR. All right, now here we have the texture and we need to connect the color output to the color input of the background node. And as you can see, we have the environment here, and here we need to increase the strength. We can test other environments, see the best one. All right, this is very good. And as you can see, we have a global lighting. For the final touch, I want to rotate and move the HDRI. It's related to texture coordinate and texture movement. I will explain later in detail, but let's add the texture coordinate and work with the simple attributes, not advanced attributes. You need to select your texture node and press the Ctrl T. If Ctrl T doesn't work on your Blender, you need to go to the Edit menu and Preferences, and you need to go to the Add-ons and search for the node Wrangler and activate it. Here we have a texture coordinate node, and I will explain it in detail later, but I need to say if you want to rotate the HDRI and change the light direction, you need to rotate the Z field, and as you can see, the light direction is changing. Right now, let's modify the strength, and here, this is very good. Alright, in the next section, we'll start modeling and some advanced transformation. Welcome to part 5 of Blender 4.5 course. I plan to introduce the modeling tools and how to shape a primitive 3D model to create a complicated and custom 3D model. First, I want to introduce something that I forgot to mention in the transformation part in the previous chapters. Here, if I select a model or light or a thing in the scene, I can move it, but I can see the transformation values here in the properties and go to the object properties. Here, as you can see, we have 3 values for the location or position, 3 values for rotation, and 3 values for scale. Here I can increase the location X. Here, let's expand this panel, and you can see the location X, and you can move it in the X direction, Y direction, and Z direction, and also the rotation, and also the scale. I wanted to say you can rotate, change the location, and also scale your object using these fields. And for example, if we want to create an object with a scale 1.5 for x-axis, you can easily do it here instead of using the shift space and scale and x. As you can see, this value is not accurate. And also I need to say each unit, each square here is a 1 unit. For example, if I insert 1, and as you can see, the center of the cube here now moved as much as a 1 square. Let's see more clearly. Scale it down here and insert 1. And now, as you can see, we have a 1 unit for each square. Also, you can lock each direction. For example, if I drag and lock 3 directions in the location, I can't move it using the G key. Now let's introduce the modeling section. To go to the modeling section, you can select your 3D model and press Tab key on the keyboard. Now we are in modeling mode, or you can go to the modeling section. Here there are no any noticeable differences with the previous section where we can press the Tab key, but let's introduce the tools here. The most important part is the points that build this 3D object. We have 3 main parts. The first one is the vertex. Vertex is this point, this point, this point. If I select this or press 1 as the keyboard shortcut for vertex, and as you can see, it's selected. We can select one of these points here. These are vertices, and move it using the G key or press shift and space and select the move tool. Here you can move and change the vertex position, or you can drag and select 2 vertices. The second component is edge. Edge is this line where a point connected to another point. You can select this or press 2 key on your keyboard. Here we can select edges and press G and move it. And the last section is polygon or face. Here we can select this or press 3 on your keyboard and select this intersection where 4 edges or 3 edges connected and build an intersection called face. And here you can select it and press G, and as you can see, we can move it. Also, we can select multiple faces or edges or vertices using the shift key. If I select this and press the shift and hold the shift key and select this, as you can see, we have 2 polygons selected. Here we can press the G key and move it. We can do it for edges, 3 edges, or vertex. Alright, these are the main components of each 3D model. And for a complicated model, we have more vertices, more edges, and more faces. For example, if you want to create a pipe, you need a cylinder 3D model and you need to shape it and curve it. And curving it needs more edges. And make sure to keep your polygon and face count small, because a big amount of polygons can be heavy to compute. Alright, now let's introduce the modeling tools. Here we have a panel on the left side. You know about these transformation tools, measure tool, but with this button we can create a cube on the 3D model. Here we can draw it, and here the depth of the cube. And if I press the left click, you can see the cube here. Also, we can draw the cube on the 3D view, and outside of the 3D object, we don't have any limitations, and this is not very useful, and I don't want to focus on it in detail. But the next tool is very important. It's extrude tool, and the keyboard shortcut for it is the E key on your keyboard. Select it, and you need to go to the face mode. It's arbitrary, but I prefer to switch to the face mode and select one of the faces, and here you need to hold this icon and press the left click and drag. Here, as you can see, a new face has been created, and we have more faces and a new part on top of the cube. Also, you can do it using the E key on your keyboard. It is very faster. You can select other faces here, and this is good. These are separate faces. You can select the move tool and select one of them, and here move it easily. Extrude tool is very useful, and I'll explain it on creating a 3D model from scratch in detail and the applications of it in depth. The next tool is insert faces, and the keyboard shortcut is I key on your keyboard. If you want the inner faces, you can select a polygon and face, and here we have a circular shape, and you can left click on it and drag. As you can see, we have inner faces here, and if I press E key to extrude, here as you can see we have this shape. For the inner section, we need to use inset faces, and for the outer faces, we need to use the extrude tool. We can make it more complicated here, and also we can add inner faces here and press extrude. This is very useful. The next tool is bevel. Bevel can make the edges smoother, and here let's select an edge, press the 2 key on your keyboard or this button and select the edge, and here we have a yellow circular icon here. We can drag, and as you can see we have a smoother edge, or you can press the Ctrl B on your keyboard. Here when you apply the bevel tool, you have a bevel menu here. You can open it and change the attributes of the bevel. Here we can select vertices instead of edges, and it will affect on vertices. You can see we have smoother vertices for edge. Here in the width type, we can select width between these options. It will change the method of the width. They haven't any noticeable differences. Here in the width, we can change the width of the bevel tool, and the segment is the most important. It will add more edges and make it smoother, make this area smoother, and as you can see we have a smoother area. Here with the profile shape, we can change the shape of this bevel. Here, this shape or this shape. We can change it. Material index is not so important. I ignore it. Hardened normals means we have hardened edges instead of smoother edges. I will explain it. How to make a 3D model hard or soft. I will explain. The most important part is the profile type. Here we can change the shape of the bevel linearly, but in the custom type, we can change the shape based on this curve. We can double click here. Here we can change the curve, and here we have a shape just like the curve. We have another shape here, and as you can see, we have a shape just like this curve. We can increase the segments and achieve a more smoother shape. Also, we can pick one of these curve methods to change the curve. And as you can see, it's harder, it's smoother, and we can change each node more accurate. Also here we can change the shape and use the default shapes. For example, support loops, or this, or this, and it's look like it steps. For the other tools, for instance, extrude, we have these options as well. Here, let's apply the extrude, and here we have the list related to the extrude tool. Here in this menu, this option will remove the previous edges, and we don't have it. And it means this is not an extra part. Here in this directions, we can change the X for the new shape, Y, and also Z. For the inset faces, we have interesting options. Here, let's apply it, and here in the thickness, we can change the thickness of the inset, and also we can use the depth, just like extrude. And here, as you can see, this is very useful. Also, we can select outer and select the outer faces. It is easy to selecting the outer faces if you want, and preventing from selecting one by one using the shift and left click. The next tool is loop cut. If you want to add extra edges to the model, we can use this tool. Here, if I select it, and the keyboard shortcut is Ctrl R. If I select the model, we have a yellow line, yellow preview edges. And if we have a loop and didn't change the structure and architecture of the cube, we can add a loop cut, loop edges. But here we've changed the structure of the cube, and we can't see a yellow edge on top of the cube. And as you can see, it's not loop. And it's better to not add edge here, because the best shape for the edges is the loop, just like here. Press the left click and drag, and you can change the position of the edge loop. And here we have this loop. In the tool option, we can change the number of cuts. Also, we can change the scale of the edges. Here we have this. And also we can change the height of the edges using the factor. If I select the even and check it, here if I change the height of the edges, as you can see, it will stick to the last edges and doesn't go further. The next tool is the knife tool, and we can add free edges. For example, here, let's add a free edge from here, from this edge to this, and press enter. And as you can see, we have a free edge and it's not looped. And we can cancel the edge drawing using the right click. Here we can add another edge from here or from this vertex to this, and this to this, here. And now we have an edge loop. We can add custom edge loops using this tool. For example, if we can't add an edge loop using the loop cut in this area, we can add just this preview, this for here, and here. For the rest of it, we can use the knife tool. Let's say enter, here, here. And here we have an edge loop using two methods, two tools. I will ignore some tools. They're not so important. Here we have the spin tool. We can select a specific polygon or face and use the spin tool. Here we can spin it, and Here we can rotate it. As you can see, we have a new shape and it uses the extrude tool but more advanced. It is useful for some works, for instance, creating the pipes in curved shapes. The next tool is Edge Slide, but it's not very useful because let's select the Edge tool and select these two edges, and we can move two edges. The next tool is the Edge Slide, and we need to select the Edge mode and select, for example, these two edges and slide and move these two edges. This is not so applicative because we shouldn't change the structure and the edge loop. This tool will destroy the edge loop, and here we don't have any edge loop anymore. Try to not use it if you don't have. And the last tool is Rip Region. We can completely move out a vertex. Here we can select this vertex and drag this circular region, and here, as you can see, the vertex is completely move out, and here we can disconnect this vertex here, disconnect this, and change the whole shape. Right, I introduced some important tools to create a model from scratch using the primitive shapes. In the next chapter, I will create a 3D model using these tools I have introduced. Before proceeding, I need to say, if you want to access to all chapters of the course, you can get it for free from blackcave.com/n/tutorial. Also, you can get access to other courses related to the 3D rendering, 3D modeling, and also game development. You can get access to many tutorials and extra chapters, advanced chapters of this course. Also, at the final, you can get a certificate and add it to your resume. Also, the link is in the description. Welcome to Blender 4.5 course part 6. In the previous chapter, I've introduced the modeling tools. Now I want to create a model from scratch. I want to create a bottle, and the primitive shape I need, press Shift A and mesh, and it's cylinder. In this list appeared here, I can change the vertices, count, the radius, the depth or height of the cylinder, and right now let's shape the bottle. Here, this height is good. Press Tab to go to the modeling mode, press 3 to go to the face mode, and here I need to press E key to extrude, or using this tool. Alright, and press S key to scale it down. Now I need to press the Shift and space and move it up in the Z-axis. Press E key, extrude, and press S key like this. Right. Press E key again, and E, and then S. Alright, and press E key again. Here I have this shape. As you can see, the extrude tool is very useful and very applicative in many 3D models. Press E key, S to scale it down, E again to extrude, and S. Right, then press E key for the top. Here I want to curve this area. Many people use extrude. For example, E and then S. E and then S. E and then S. But I don't want to use this method because it's not accurate and take a while. Instead, I can use bevel. Press the 2 key to select the edge mode and select this edge loop. Instead of selecting multiple edges using the Shift key, I can press Alt and left click to select the edge loop. No, the edge loop is selected. And press Ctrl B or this button to apply the bevel. And here I have a bevel, but the previous operation has been applied here. I need to select this for profile type, and here this is good, and I have a curve here. Increase the width and decrease the segments. They are very high. Alright, good. Now I need to remove the top area. Here I need to press the Alt key and select the poly group. The face mode is active, and press Shift and left click to select this area. Press Delete button, and here in this menu press Faces if you want to remove the faces. Alright. Now go to the edge mode using the 2 key on your keyboard and Alt and left click to select the edge loop, and press the E key to extrude. But as you can see, we have a free extrude tool and it's not good. I need to press the right click to cancel it, but the new polygons have been created. I just need to move them up manually. Alright, press E to extrude again and cancel it. Press S to scale it up and E key again, and here I need to move it up manually, and this is good. Here I need to fill this gap, and I can use the face menu and then press fill or grid fill. Let's see the differences here. This is a fill. We have irregular shape and edges, or use grid fill, and this is so better. Now I've destroyed the edge loop actually, because if I select the Alt and left click, which is useful for selecting the edge loop, you can see these areas have not been selected. I need to press the Shift to select multiple edges and Alt and then click, and here again and again, and I need to bevel it. Press Ctrl B and here bevel, but I need to decrease the segments, and one segment is better. Be careful about the width. Alright, good. Here at the center I want to apply a specific shape like steep. I can use actually the loop cut and also the bevel. I can use the loop cut. Here select the loop cut, and here select this edge loop and press left click to apply. Now I want multiple cuts. Here I need to increase the number of cuts, and this is good. Alright, now I have multiple cuts on the mesh. Here let's select this edge loop, Shift and Alt this, yes, this, and it's good. And I didn't need to press the Shift and space and scale. Here I need to change the scale Z, scale X, next scale Y. Alright, this is good. As you can see, we have hard polygons or faces here, and this is not good. I need to smooth it. I need to select the mesh and the default view, not modeling view, and select the mesh, right click, and here we have 3 options: shade smooth, shade auto smooth, and shade flat. If I press the shade flat, I don't see anything because this object is currently flat and has hard faces. If I press the shade smooth, as you can see, we have a smooth object, but destroys some necessary hard edges. Here I need to have hard edges here, and for this area here, and this is not good. So we have an option Shade Auto Smooth, but it has some issues. Let's select it, and as you can see here we have a better shape here, and this is smooth. But here, as you can see, we have hard edges. This is good, but in this area we don't have hard edges, and I need to fix it manually. Here I need to go to the modeling mode and edge mode and select these edges. Press Shift and Alt here. Alright. Right click or go to the edge menu. I prefer right click, and here mark sharp. Press mark sharp. And as you can see, we have the sharp edges. You can do it with any edges you want. For example, this edge as well. Here, Alt and left click, right click, mark sharp. And this is very good. We have a beautiful bottle here. In the next part, I will explain how to create color and material for it, and I'll deep dive into the material and shader design. Also, you can get this bottle with its materials and textures at blackcave.com/store. Welcome to Blender 4.5 course, part 7. In the previous chapter, I've built this bottle and introduced many features in the modeling. I will create another model later in the future chapters and work with other tools and other features in Blender. Now, in this chapter, I want to talk about the material, shader, and coloring in Blender. How to apply a color, lighting features, shadowing features, and so on multiple 3D objects. Here I have the bottle. Let's add another object, the cube, and also a sphere. A UV sphere is good. Here, as you can see, the sphere is a hard surface, hard edges, and I need to select it as I explained in the previous chapter. Right click and shade smooth, and as you can see, it's smooth surface, smooth edges. Right. For shading and apply materials, create materials, you need to switch to the shading mode. Here, as you can see, we have a different environment, a different lighting. We have a ambient light, but it's not final render, because if you press the Z key or look at the top, we are in the material preview, which we can see the colors, material attributes, and so on. The lights doesn't work here, and we have only a light just for watching the differences and the result of the materials. Now let's explain what a material is. Material is a package that you need to add your textures and details. Texture is the color and the image that will apply on your mesh or your 3D model, and you need to connect and add that texture to the material. And also you can specify some details on the material. For example, the level of roughness, the level of details, and extra features, the level of metalness, and so on. You can add many custom features to the material. If you select your mesh, here I'll start with sphere, and here in the shader editor, you can also open the shader editor here, select this and shader editor. You can open the shader editor here as well. Press the new button to create a new material. And here we have a structure just like before in the HDRI lighting. Here, if you remember, in the previous chapters, in the lighting section, I introduced here and we connected some nodes and apply an HDRI lighting to this scene. In the object mode, which we can add and assign materials to the 3D objects, here we have a node-based environment just like HDR lighting. These two nodes and also all nodes we will add to the scene are our material. And this node is a shader. Shader is a piece of code that written by Blender, and we can add many shaders, and each shader has several attributes and properties. If we press Shift A, we can access to all nodes that exist in Blender. For example, if you go to the shader, we have all the shaders provided by Blender. Here, Principled BSDF is the shader we have in the scene currently already. Also, we have other shaders, for example, for volumes, Principled Volume, for clouds, mist, and so on. Glass shader for glassy surfaces, emission shader for glowing surfaces, and so on. Also, with the add shader and mix shader, we can combine two or multiple shaders with each other. We can create a complicated material and add many nodes and combine them. We will explain about it later. Actually, I can't explain about all the nodes here. We have a lot of nodes in Blender, and some of them are unnecessary for this course. I will explain and use the shaders based on our needs in each chapter. For this sphere, I want to use a simple material, and I don't want to use any specific node, but for the other 3D objects, I will use extra nodes. Here in the Principled BSDF, which is the most advanced shader provided by Blender, it has many features. The first one, the first attribute is base color. Before that, I forgot, the BSDF result is connected to the surface. Surface is the final material related to the object. If we press the control and right click drag, you can see the object doesn't have any material and color, but in this case we have. The surface is the final renderer, and we need to connect the BSDF or the shader result to the surface. This is very important. You need to connect a shader to the surface finally. Doesn't matter how many shaders you have in a material and how many connections you have. You need to connect a shader result to the surface. For example, if I add a diffuse BSDF, it's very small and just 3 inputs here we have. If we connect it to the surface, we have a result as well. Alright, the first field we have is the base color. Base color is the main color of the 3D model. We can change it, we can make it darker, and here we can change the type of colors. As you can see, just the values and attributes will be changed, but the coloring won't be changed, and there are no differences. Here, if we increase the hue, as you can see, we are changing the whole color, and look at this circular shape. If we change the saturation, as you can see, we have a wider color when we have a small value, small amount of saturation. With the value, we can control the color brightness. We have a darker color with a small amount of value field, and here we have a brighter color. Alpha is the transparency, and I don't want to talk about it right now, but first we need to talk about the alpha field. Also, we can connect a texture to the base color instead of a solid color. Actually, we can connect an image to the base color. Here we have an input node. Input node can take an input and another node. I will explain it for the other 3D models. Here we have the metallic section, and as you can see, the surface is now metalless, and you need to increase or decrease the metallic section based on your needs. This is beautiful for metallic section, metallic areas. For the roughness, we can specify how much our 3D model is rough or wet. Here, this is completely rough and doesn't reflect any light, actually, in a simple word, but with small values of roughness, as you can see, we have a reflective surface, and you need to adjust it based on your need. For example, a camera lens has a value like this, or a water surface has a value like this. Alright, the next section is IOR, or index of refraction. Actually, it specifies how much our surface will reflect and spread the light. For example, if we have bigger values, as you can see, our model is spreading the light much bigger than the previous value. And here, if we have a rough surface, and here, as you can see, we have more spreaded reflection, actually. For instance, for the water surface, this value works, even 1.4, like this. But for a plastic surface, you need to increase it, because plastic surface has more spreaded reflection. Alright, now let's talk about the alpha. Alpha specifies how much our surface is transparent. As you can see, if we decrease it, here we can see the other side, and our model is semi-transparent. And here we can't see the object anymore. We can assign a texture, a black and white texture, to the alpha, and white areas mean we don't have any transparent area on those areas, and black areas, black colors, means those areas are transparent. And it will apply to the alpha, and we have a pattern finally. Here, this is the normal or normal map. Normal map applies some bump areas on the surface. We can't easily assign a normal map. We have some steps and complexities. And also, if you want to achieve a very realistic and good normal map, you need to use 3D texturing software. Also, you can add textures to your object in the texture paint. I will work it later, and add normal map to your object. I don't deep dive into it for now. It is a more complicated section. I will talk about it later, but only I can say texture, the normal map texture, is a kind of blue texture. Actually, I will show you several textures for the base color, metallic, roughness, and normal map at the end of the video. Alright, I will ignore some specific sections, for example, diffuse and diffuse roughness. It is not so important as much as the others, but subsurface scattering, I'll ignore it because I want to record a complete tutorial on it, and it has many features and it's too complicated. It should be a separate video, and it's not good to explain this section in this video. Specular, actually it does look like the IOR, but IOR is kinda new in Blender. But specular is a traditional aspect in all 3D tools. You can specify how much your surface will spread the light and reflect the light, and it's so better to work with this section, not IOR, because you have more control. Here you can specify what the method of your distribution. Multi-scatter GGX will give you better quality. Here in the IOR level, you can specify how much light should spread, just like here, but we have a limitation in this field. Beside that, you can change the color of reflection. As you can see, Now we have a red color on the reflected area, or blue color, or you can assign and connect a texture or image to the tint because it has an input node. The next two attributes are anisotropic and anisotropic rotation. Will add a horizontal reflective area on your surface with anisotropic with this value, but we can't see any noticeable differences here. I don't know why, but let's switch to multi-scatter. In many type of surfaces and 3D models, actually we don't need to change the anisotropic, but if it applies to the surface, it will add a small amount of horizontal reflection to the surface, and also anisotropic rotation change the rotation of that horizontal line. You can change the direction of it. Alright, the transmission section related to the reflection, you can make your surface reflective. It is different from metallic section or roughness section because it is very useful for something, for instance, mirror, and it is different from the roughness, as you can see. The next thing is coat. Coat will add more wet area, focused wet area on the object. No matter how much your roughness value is, for example, we have a rough 3D model here. Let's add the coat. Let's change the weight. And as you can see, we have more focused reflective section on the surface. And it is completely wet, while the roughness value is 1, means it is completely rough. And actually it works in a different channel. As you can see, we have a different reflective area, and this is completely separated from coat. In some other 3D tools, it also called clear coat, and it is very useful for glasses and mirrors and so on. Also, you can change the roughness. Clear coat has a roughness value that is different from this roughness. Also, you can change the IOR, or index of refraction, here for the clear coat. And you can change the tint or color of the coat. The next thing is sheen. Let's turn off the coat. Sheen will add and highlight around the object. Here, as you can see, the sphere around of the sphere is shining, and no matter where the direction of the camera is. And you can change the roughness of it, which with the low value of the roughness, the range of the highlight is smaller. And here we can change the tint. It is very useful for glowing object or add rim light. Rim light is a technique to adding highlights to the object, and you can use the sheen based on your needs. The next thing is emission. You can add glowing effect on your object. Here we have a red color and we need to change the strength. And as you can see, our object is glowing. We can add real glowing. I will focus and explain on post effects and post processing later, but this is the emission, basic emission, and it's ready to add post effects to it. Right, the last attribute is not so important, and now you're ready to add materials to these two objects. I will add and introduce more nodes and also introduce the textures for these two 3D objects in the next chapter. Welcome to Blender 4.5 course part 8. In this part, I will introduce some nodes and connect them to these inputs. In the previous chapter, we learned about these inputs and output and shaders, and also how to modify these fields and the capabilities and properties of each field and input. Here we will work on these three objects, and here let's press Shift A or press Add. You can add nodes using the Shift A, this add menu. And in the previous chapter, we worked with the shader section. Now let's work the texture section. Here we can add several patterns as textures to our material. We can add images to the Blender as textures. For example, a human face has a specific texture that make it in ZBrush, Substance Painter, Mari, and so on. And in the case like this, we have a PNG or other file types, and we need to add it to the Blender. I will do it later. But now we have pre-made textures in Blender that we can call them procedural textures because we can customize them using some specific fields. Let's start with the first one, brick texture, here added to the environment. As you can see, we have many inputs here and we can modify them and customize our texture. To see its effect on the object, you can connect the color to the base color because it gives you a pattern that you can connect it to the base color and see the color and result. Also, you can connect it to the metallic section, and a metallic pattern will be applied on your mesh, and roughness to rough and wet areas. But we have another output, and also we have another option to preview the texture. We can press the Ctrl Shift and left click on it and make sure here in the edit and preferences and in the add-ons, Node Wrangler is active. And here press Ctrl Shift and left click. As you can see, the color is connected to the surface. You can connect it directly without pressing the Ctrl Shift and left click. And as you can see, we have a preview. It's a preview of the texture, not shader. And here shader is completely disconnected and we can see it. And here we have some distortions because it's sphere. We can apply it on the cube. Here, if we select the sphere, as you can see, the current material is material 001. We can change its name and change it to brick matte. Here in the cube, we can search for the material, and here we have the brick material. If we change the material here, the material on the sphere will be changed as well. Alright, we can see the brick texture here. So what is the FAC? You can press Ctrl Shift and left click to switch to another output, and here you can see the FAC. FAC is another representation of our texture. In some textures, if you connect the color, you face with an RGB color. And if you switch the FAC, will face with the grayscale. But brick texture just provides the grayscale texture, and with the FAC version, we have another representation of the texture. Alright, this is the main concept of texturing in all 3D software and 3D tools, also game engines. If you know about the main concept of texturing and how to apply the textures and how does the textures apply to the inputs, you can make many effects on material editing section. Alright, let's work with other textures. Here press Shift A, and in the texture we can add the checker texture. Here press Ctrl Shift and left click, and here you can see a simple checker texture. And also let's press Ctrl Shift and left click again and see the other effect of the texture provided by FAC output. You can change the color A and color B, and also the scale. It's a simple texture, and you can do it to roughness, and here we can see some areas are rough and some areas are wet. Alright, The next texture is environment texture. We already know about it and worked with it in the lighting section, which we need to switch to the world. And here for the HDRI, we need to add an environment texture and load an HDRI and here connect it to the background. It's not very useful in the object texturing. The next texture is Gabor texture. And here, let's see it. As you can see, it provides something like wrinkles. And here we can change the scale, frequency, which higher values gives you smaller distortion, and also the scale. The next field is anisotropy, which is related to the distortions. Smaller values gives you more distorted effect, and also you can change the orientation of the effect. Also, you can change its type. It's 3D or 2D. You can apply it on the surface, the entire surface, based on the 3D view, not 2D. On the 2D scenario, it considers the current 3D model is a 2D surface, not 3D. It will cut some edges in the background and we can't see the process, and applies the 2D, actually projects the 2D texture on the 2D spreaded object. We will talk about this process and we will do it manually in the UV mapping section. Alright, here we have three outputs: the value, the phase, and the intensity. Here it provides three values and you can use them based on your needs. Alright, the next texture is gradient texture. Here, as you can see, we have a gradient effect. Also, you can see the effect, and as you can see, there are no differences. Here you can change the gradient type. It's linear, you can change it to quadratic, easing, diagonal, spherical, quadratic sphere, and radial. But how can we change the position of the gradient and increase it? Increase the black areas. Here we have a vector. We have actually a vector input on all textures. And we can press Ctrl T, just like the lighting chapter that I explained about Ctrl T, and we can add texture coordinate. And here we can change the location X and change the position of the gradient. The Y value is not working here, and also the Z. In other scenarios, if gradient was on top, you can change it, change the height using the Z value, because Z represents the up, and you can see it here. If the black area was here, you could change it using the Y value. Alright, here let's change it, and also you can rotate it, not with X, using Y and Z. Also you can scale it, just like the location X is working, not Y and not Z. You can connect this mapping node to the vector of these textures and see the result. We will work and create a material from scratch, a great material from scratch, using some of these textures, especially the gradient, which is very useful to make fogs and volumes, which we have more intensity on the top and for mist, and very useful, and gradient texture is very useful for creating fog, mist, and so on. The next texture is IES, but I'll ignore it. It's not important as much as the others. The image texture is related to external textures that I explained. If you create your texture in ZBrush, Substance Painter, or Photoshop, or also Blender, but you have a PNG file or JPG or other file types, you can load the texture using the image texture. I will do it later in detail. The next texture is magic texture, and you can press the Control Shift and click, and you have this effect. We have the RGB color in this case, and you can receive the grayscale value by pressing the Control Shift and left click and actually using this effect output. Right, you can change the depth and change the structure and the color of the magic texture. Also the effect is changing the scale and the distortion of it. It is very useful for creating some distorted areas, for instance, the water surface, or an effect like oil on the water, and so on. Alright, the next texture is noise texture. Is the most important and useful texture in Blender. Here you have an unstructured noise texture. We can change its type. It's 3D, 2D, 4D, 1D. I just focus on 3D for now. We can change its shape. It's multifractal, ridged multifractal, which gives you some black waves. Hybrid multifractal, FBM, which is the default type. Heterotrain, which is look like the hybrid multifractal. You need to choose based on your needs. Here you can normalize or actually limit your values on the surface. For example, if we have value between minus 20 and 20, normalize will change it to something between 0 and 1. And if you uncheck it, as you can see, we have a bigger values. Here we can change the scale, details, and it will add some small details to the surface. And as you can see, with the 0 value we have a smoother noise. Here, using the roughness, we can also add something like detail. Here we have smoother result, and here it is detailed. With the lacunarity, you can add something like micro noise to the surface, and you can add distortion to the result using the distortion value. And as you can see, it's not regular and unstructured, and very useful for many surfaces. I'll ignore point density and sky texture, and the next texture is Voronoi texture. It is important as well, and it gives you some spots and points, and here we can change the scale of it, the details of it. It does just look like the noise texture, and I will not explain some fields from scratch. It is very similar to the noise texture. Actually, in some other software, it comes with noise texture. Here you can increase or decrease the roughness. It is similar to the noise. We have detailed noise, and we have an extra field called random. We can set it to 0, and we don't have a random shape. Alright, we have two fields. You know about the projection, and I explained it in the noise, and also the type texture. We have different types here, but we have a distance field. You can change the method of distance calculation between each point if we decrease the details. Here we have these points, and we can change the distance calculation method. Here the Euclidean distance is chosen. We can change it to Manhattan or other distance calculation methods. Also, you can check the normalize. We have a distance output here, which it provides a grayscale output. We can change it to color. We have a color output, and also we can access to the position output. Here, color and position are RGB, but distance is grayscale. We can convert the RGB colors to grayscale and vice versa. Also, we can invert a grayscale, for instance, converting the white areas to the black and vice versa. But I'll explain these concepts in the future videos. The next texture is wave texture. Press Ctrl Shift and click. And here we have these lines. We can make waves using these lines. Here we can change the wave type to rings. We can change the direction, and also we can change the shape of the waves. Right. The scale value increases the wave count, the lines count. The distortion gives you an effect like wave. Actually, the distortion value is the most important part in this texture. You can add details to the waves or make them smoother. You can change the scale of the details. You can make the details rough, or you can change the offset of the waves. As you can see, these waves are generating in real time and they are procedural. This is using some codes to generating new waves based on some algorithms. Also, at the output, we have the color and effect, just like other textures. Alright, the last texture is not as important as the others. Let's ignore it. And these are the main textures we will use in the future videos. And also, you know about the concept, how to apply the roughness, metallic, base color, and so on. Actually, you know about the core concept of material design in 3D tools. In the next section, I'll focus on creating a serious material for these objects. Welcome to Blender 4.5 course part 9. In this chapter, we will continue the material design in Blender. In the previous chapter, I introduced the texture nodes, and you already know about almost all of the texture nodes. Procedural texture nodes, which we can balance and adjust the attributes of each texture and generate the texture in real time. And this is the procedural texture. Now I want to make 3 materials for these 3 shapes. Let's start with the cube. I need to delete these nodes. They're related to the previous part. Here, Control Shift and left click to see the result, or you can connect the BSDF output to the surface directly. Right, now let's create a marble material using the procedural textures. Press Shift A to add a noise texture. Here, press Control Shift and click to preview it. And here we need to adjust the attributes. Increase the scale, increase the detail, and we need to adjust the roughness and a little bit of distortion. Alright, here we need to press the Control Shift and click and connect the fact. Here we have a color output as well, but we don't want to use it. We need a grayscale or black and white marble. We need to connect effect to base color. Also, I want to introduce a new node. Here, if we want to assign a color to the black or gray areas and assign a color to whiter areas, we have a node called Mix Color here. And we have a color A and color B. And also we have a factor. Factor adjusts the colors. For example, if we pick the red color and here we have a blue color here, we need to connect the result to base color. And here, as you can see, we have a purple color. And we can adjust it using the factor. If we increase it to 1, as you can see, we have a blue color. And if we decrease it to 0, we have a red color, the first value. So we realize that the 1 value is near to the color B and the 0 value related to the color A. And here 0.5 is a color between these 2 colors. So what happens if we connect the fact to the factor? Here the gray or black areas related to the A, and wider areas related to the color B. And as you can see, we have this result. I just wanted to introduce the mixed color node. I will work with it later on other surfaces. Right here we have the base color. We don't need to increase the metallic. Marble doesn't have metal value. Here we have the roughness. We need to decrease it, and we need a kind of wet area. Right, this is so good. Also, you can assign the factor roughness, but it's not work in most surfaces related to the marbles. It's not good. We can add some areas, dusty areas, or fingerprints on the surface and assign it to their roughness, but assigning the fact to the roughness is not good. Alright, the next one is the IOR that I've explained earlier in the previous chapters. We can adjust the IOR and the light distribution in the specular as well. Here, as you can see, we have more light reflection here. Alright, let's increase it a little, and this is good. Also, we can add a little bit of coat, which is the detailed roughness, and here we can increase the weight, and as you can see, we have more reflection, and this is good, and increase the roughness a little. Also, we can add more details and another noise node. Here we need to select this node or add another noise texture and press Shift D to duplicate it. And here press Ctrl Shift and left click and adjust it to add more details. Here increase the scale, set the distortion to 0. And here we need to increase the roughness. And as you can see, we have a beautiful effect. Alright, now we need to add these two textures, mix these two textures, and assign it to the base color. Here we can use the mix color node that we already know about it. Let's add the mix color and also math node. In the math node, which we need to connect the grayscale values, or in another word, black and white values. Here we have extra operations. We can apply extra operations on black and white values. For example, subtracting, multiplying, dividing, power, rounding it, floating it, and so on. We have many mathematical operations here. In this scenario, which we need to mix these textures together, we can use add operation. Also, you can change this mix to add. It also works. We can utilize these two nodes. There are no differences for our scenario. Alright, let's try this at first. Now, if you press the Control, Shift, and click, you can see the result here, here, and the combination of them. We can see the details here. Here we have detail, but in the add operation we don't have it. It's not so clear. We can change the operation. The second operation one is multiply. As you can see, the multiply is very better. Here, let's see. This is the first noise, this is the second noise, and this is the combination of both. Also, we have an operation called multiply add, and here we have an extra field. We can decrease or increase it, and we have this effect. But I think multiply is better. Here we can use the mix color and change it to multiply. Here we can connect this effect and this effect, and let's see it. Also, we have the factor that we can adjust the results. Right, as you can see, these two nodes provide a similar result, but I prefer to use the regular math node here. This is the result. Also, we have another node called brightness and contrast. Here we need to go to the color and brightness and contrast. My plan is to introducing the useful nodes that you need in your workflow. Here we can change the contrast and brightness of a result. Here we need to connect the factor and see the result. Control Shift and left click. Here we can change the brightness, also the contrast. Contrast makes the dark areas darker and the bright areas brighter. And we can now connect the result of the brightness and contrast to multiply operation here. Now we can change the contrast in real time. Alright, as you can see, the marble material has applied on the sphere as well, and it's very good and realistic. Alright, now let's make a wood material for the sphere. Here we need to select the sphere and press this button to unlink the material. The material didn't destroy. Here we have it, and we can select it from the list and press new. And here change the name to wood mat. For the wood material, if you have a reference, you can see we need a wave texture. Press Control Shift and left click. You can try it on the cube as well to see the structure better. Here we need to change the distortion, right? Now it's look like a wood kinda, and increase the details, and here, and also detail roughness little. Now we have a good result. If you increase the distortion more, you have an effect like marble, not wood. Right, we don't need to change the type, the wave type, the direction, and also the shape of the waves. Right now, as you already know about the mix color, we can add a mix color here and connect the color. As the color provides a grayscale, we can connect it to the factor and connect the result to the base color and see the result. Now we need to set a color for the A and a color for the B. Color A should be a brownish color, and color B should be a brownish as well, but brighter. And here this is the result. Okay, we can make the roughness just like the marble. Here we can achieve this result, but I don't want to add. I want to add some bumps on the surface, just like wood texture. Here we need to use the normal map. As I explained earlier, normal map is useful for add bumps on the surface. Actually, when you make your textures in the Substance Painter, ZBrush, or Blender even, and export your textures, you have PNG, JPG, or TIFF files. That your normal map looks like a combination of purple and blue colors, and you easily need to connect your texture, your blue and purple texture, to the normal map, and you can see some bumps will be added to your surface. But here we don't have a texture, so we need to use the procedural textures. How to add some bumps to the surface? Here we need another procedural texture, and I think Voronoi texture is good. Press Ctrl Shift and left click, and here we need to increase the scale. Right, this value works. The next step, I need to change this distance to normal. Normal is a vector-based value, which we saw in the mix color. Here we have the vector value, and normal map is a vector type. We have a lot of ways to create the normal maps, but the easiest way is to press Shift A, and in the vector we need to add a normal map. And here we need to connect the distance to color and normal to normal map. In this way we don't have too much control on the surface, but let's see the sphere on the surface, but it works. Here it's not so good. We can increase or decrease their strength. In this scenario, we need to decrease it here. Now, as you can see, we have some details on the surface. We can decrease it more. Also, I've applied it on the cube as well, and you can see the surface without normal map, with normal map. Here we have some bump areas on the surface. Also, you can connect the wave texture to the roughness, but before that I need to connect it to the contrast and brightness. This is not good for the roughness. Here, let's connect it and see the result. As you can see, it's not good. These areas are too rough and these areas are too wet, and this is not the ideal result. Add a brightness on and contrast node, and here we can change the brightness and also the contrast. Here, this is better. Also, these areas are too rough, but the wet areas are good. And I can change it because the entire surface will be affected by the changes. I can add coat. Here, I can increase the weight and increase the roughness. Alright, this is good. We have a roughness in the layer below, and at the top we have a coat. We can make the wood texture very better. We can add another wave texture here to add some details. Change the distortion, decrease it, and increase the detail scale, detail roughness. And here, let's connect it to the contrast and brightness. Here, this value works. And use mix color or math and use multiply. Connect this and this, and finally connect the value to the factor. Here, press Ctrl Shift and click to see the result, and this is our result. Let's disconnect the roughness and see the result. This is better, I think. And good. Let's see the cube. Alright, good. The next is bottle. Actually, for the bottle, we need to use a texturing software because it's complicated. We need some logos here for the bottle. The top of it is different, and it's kind of different to use procedural textures for it. But let's create a simple material for now. I think simply we need to assign a color here. Alright, this color works. And the next thing is to add a little bit of metallic value and decrease the roughness. Alright, this is very good. And also, we can decrease the alpha a little. Now we can see the other side. Also, we can add a wave texture to add some roughness, like this pattern here. Press Shift A, texture, and wave texture. As you can see, it is not good because we don't have UV on the surface. I will explain about UV in the next chapter, and it is so important for the models. Also, if we change the direction, as you can see, the result is not good anymore, and we need UVs. But let's try for the test. Change the distortion, add some details, and here we need to add a contrast node to balance the contrast and connect it to the roughness finally. As you can see, we have some areas, some wet areas on the bottle. Let's increase the alpha, and as you can see, we have some wet areas. It's not look so good, but actually works for basic bottle material. Also, you can add coat. Alright, good. This is the basic material design in Blender, and I've also explained about the procedural textures in Blender. In the next chapter, we will work on the UV unwrapping and starting the advanced texturing to add more realistic and serious textures to our surfaces. In the previous chapter, I explained about the material design in detail. As you can see, we have created these materials and also a marble material that I've removed it. Now I want to explain about more advanced features, a concept called UV unwrapping. It will give you an ability to create the textures, advanced texturing capability in ZBrush, Substance Painter, or even Blender or Photoshop. Before you want to add the texture and make the textures for your 3D model, you need to have a 2D structure which is represented by the 3D object. But you need to define the rules and structures that how does your 3D model should represent the 2D view. And on the 2D view, which we call it UV, you can apply and make your textures. For example, consider this sphere shape, this 3D shape, and we need to make it 2D for texturing. We can apply a UV unwrapping to achieve this result. And now at the right side in the 2D view, we can create the textures and apply textures to it. And Blender or other 3D tools will convert the 2D shape to 3D shape, and we can see the texture on the 3D surface. Alright, let's get back to the solid mode using the Z key. Here I will explain how to create the UVs from scratch, and I'll start with this cube, and then sphere, and then bottle is more complicated 3D shape. Right, let's select the UV editing section, and here we have the UV, and also we are in modeling mode. If we press tab, now we are in the object mode. Alright, we need to be inside the edit mode, modeling mode, and create the UVs. Here at the left side we can see the UV tiles. If we select the polygon mode or this or tree button and click on this section, you can see the UV tile related to the upper face is this, and this face related to this section here, as you can see. If we press the A key to select all the polygons, you can see the whole structure. As you can see, each face, each polygon represents a shape in 2D view. Actually, we are converting the 3D view to 2D view for texturing. So, how to do it? And it is more complicated in complex objects. Consider we have a human face, or a complete body of a creature, or a car. It is so complicated for those objects. But for the cube is simple. We just need to cut some edges, but not real cut, not actual cut in 3D mode. They are cuts for the UV, for the 2D shape. If we make a cut here, then here, and then here, we can separate this polygon, but this section, this edge is sticked, and we can't completely remove this. And just we have a 2D representation of a cube. Let's do it. First, as you can see, we have a UV on the cube. We need to remove it. We need to press the U key, and this is the UV related menu, and press reset. And now we don't have any UV on the cube, and now we need to go to the edge mode. Press this or press 2 on your keyboard. Let's explain about the cuts or seam. Here we need to select this edge, this, and this, and edge loop actually, and press U. And here we need to select the mark seam. Mark seam mean a cut. And now these four edges has been cut out. As you can see, they are red. They have a red color. And then go to the polygon mode and press A. And then press U. And here we have three options to unwrap the UV. The process of converting or creating a 2D view based on the 3D model is unwrapping. We have three options. Unwrap angle based, so we have this result. Unwrap conformal, we have this result. And unwrap minimum stretch, we have this result. You can select based on your needs. I will select the unwrap angle based. As you can see, this polygon is this in 2D view, but the rest of it is this, the rest of the cube. And it is not good because we don't have any cuts on other edges. And here, if we wanna convert this section, this, to a 2D shape, it will be stretched and we have a pressure on it. And we can see here we have a pressure. In the 2D view, if you press the 3 button or this option, we can select the polygons. Here, if we select this, we can select the polygons and change the position of the 2D shape. But as you can see, this shape won't be changed. Actually, it's a 2D view for texturing. It is not an actual modeling view. Anyway, if we select this, as you can see, this little polygon is related to this polygon. And the shape of it is not good, the size of it is not good and correct because of the pressure applied on this face. If we press the 2 key and in the edge mode, select this edge loop and mark seam or cut this edge loop. Here, if we go to the polygon mode, press A, U, and unwrap angle based. As you can see, we have two polygons here. This is the first one and this is the second. And we don't have any pressure on these two polygons. And here we have a pressure on the rest of the polygons. So the question is how to remove this pressure. We can do it in many ways. For example, go to the edge mode, select this edge, press U and mark seam. Now, as you can see, we have a cut here and consider this polygon loop will be cutted here. Now the edge will be destroyed. And now we don't have any pressure anymore. Go to the polygon mode and unwrap base. As you can see, we have a correct structure. We don't have any pressure because this polygon is completely separated. This is separated. And we have a cut here, and we don't have any logical pressure on the 3D object. And this object can be converted to a 2D shape easily. Now, as you can see, these two shapes are separated completely, but we can't move easily this shape. And here, these sections are separated. Exactly this edge. But actually, all of these polygons are connected to each other. Also, we can press S to scale it down or scale it up. We can press G to move it. You can press the R to rotate it. It doesn't affect on the 3D view and so on. In another word, you can move easily the polygons if the polygon is disconnected and separate from the other polygons. You can move it easily. Now we have a UV shape. You can apply another structure. For example, here a cut here, cut, don't cut this section, cut here, and connect this polygon, this together, and this, and this together. And we have 2 tiles, not 3 tiles. Here we have 3 tiles. You can apply many structures for a single cube. So what is this UV? What can we do with this UV? First, I need to say, try to scale it down a little, because actually it's kinda dangerous that this edges are over on the UV border. Don't do it. And get a distance from polygons to the UV borders. So now we have a desired result. And actually I need to say this square shape is a texture, and we need to export this texture and paint on it. If we paint something like high text on this polygon, a high text will be displayed on the top section polygon. And actually this is a 2D view or texture related to this cube, and we can paint on it and create texture based on this view. Alright, it's better to press A to select all the polygons and go to the UV, and here export UV layout. Alright, now here we can export the UV view, the texture view, as a PNG, JPG, or other image types. Here we can define the size of the image and resolution. The fill opacity is the alpha channel of the UV view, and if we set it to 1, we don't have any transparency on the result. Here this value is good. We can change the size of the UV. It doesn't matter because we can change it in Photoshop. Alright, we can change the format to SVG, EPS, or PNG. We don't have any other formats. Here we can change the type of the tiles. We can export UDIM if we have multiple UV tiles. If we had multiple UV views, they will be called UDIMs, and that's the advanced concept UV mapping, and I will work on it later. Alright, now press the export UV layout. Right, as you can see, this is the result, and this is look like this is look like this shape. And we can open this image inside the Photoshop or Paint and actually paint on it, or place a texture or an image on the tiles. Alright, here we are in the Paint software, and I need to say something. Here, this is the empty space, and if we write or paint everything on it, we can't see them on the model because these sections are important. These are the polygons. Alright, let's paint something on the polygons. Example high, and here cube. Alright, press Ctrl S to save it, and now we have this result. Alright, now we need to import the texture to the Blender. Here, go to the material view, and in this section we need to remove the material on the surface and create a new material and call it cube matte. Alright, now as I said earlier, we can connect something to base color, a color, texture, an image, or anything else. Right? You can remove this menu if you want using the N key on your keyboard. Alright, Here we need to drag and drop the cube.png texture, or you can press Shift A, texture and image texture, and open your texture. There are no differences. Here, if you press Ctrl Shift and left click, as you can see, we have the high text on the top polygon and cube text on the bottom polygon. And this is what we write on the cube. Actually, if you go to the UV mapping, here as you can see, the 2D shape is converting to the 3D shape. And as you can see, the image applied on the 3D cube, the 3D shape based on this view. All right, can connect it to the base color and see the final result. All right, let's create a UV for the sphere as well. Here we have a complicated UV on the sphere. Press A to select all the polygons, U, and then reset. All right, here we need to add seams or cuts. We can follow many structures. For example, this edge loop, we can cut it and then create the UVs. We can use this edge loop, or we can apply multiple cuts like this. But I prefer to use this edge loop. Press 2 key on your keyboard and then Alt and left click. Here we have this edge loop. Press U and mark seam. All right. Press 3 on the keyboard, press A, U, and unwrap angle waste. As you can see, we have a good structure. Here we can scale it down or up and also move this section. Right, we have this structure. Press A, UV, export UV layout, and then here press export UV layout. All right, I'll work on this texture in Photoshop. As you can see, we have a layer, a transparent layer here, and represents the UV. We can add an extra layer for the colors and fill it with this color. And actually another color, this is a UV color. Here let's select this color and write something. Okay. All right, now we can remove this layer. This is not important. It is very useful to recognizing where the painting should apply on the polygons, but here we don't need it. And now let's export the texture. Okay, this is result. Now let's import it to the Blender. Here, create a new material, sphere mat, and here we need to import the sphere, drag and drop, and apply it to the surface. Now, as you can see, we have the OK text here and high text here. And in the UV editing, we have this structure. 2D shape is converting to 3D shape, actually baking the texture on the 3D view, the 3D surface. All right, the bottle shape is more complicated, and I will do it in the next chapter, and also create the textures inside the Substance Painter, more complicated and more realistic textures. In the previous part, we've introduced how to make UVs for the 3D model, and I've applied textures on this sphere and this cube. Now I want to create a UV for this model, which is more complicated. All right, let's create the UV for this model, 3D model. Go to the UV editing. Here I need to remove the current default UV. Select the polygon tool or tree on the keyboard, press A to select all the polygons, press U on the keyboard and reset. All right, now I need to add the seam or cuts in some areas that it's necessary to remove the pressure. For example, if I want to create a UV for this cone shape, I need a cut here, a cut here, and a cut here on the top. So with this, we will remove the pressure, and we can easily convert a 3D model to a 2D representation. Here I need to go to the edge mode using the 2 key, press Alt and click to select the edge loop, and then press Shift and Alt and click here. Here we have 2 edge loops, and press U and mark seam. Here we've cutted these areas, and here we need another cut. But if I select Polygon tool, A, U, and create a UV, as you can see, the structure is not good because everything here is not correct. Actually, we have pressure on the current UV because we can't create a cone 2D representation without a vertical cut. Here we need to select a edge and press Alt to select the edge loop here. As you can see, we have an incorrect edge loop. We need to unselect this edge loop. We just need this. We need to press Control and drag, and here alright, actually I need to remove this and also this. Alright, press U and mark seam. Alright, here press A in the polygon mode and unwrap angle base. Here, as you can see, we have a correct UV map. We need to do this for this section as well. Here, too. You can select using the Shift, not using the Alt. And also press Alt and Shift to select the edge loop here. And this section now is separated. Right, and the bottom is good. Press 3 button, A, U, and unwrap angle base. Alright, as you can see, we have a good structure. It's correct. We don't have any pressure, as you can see, on the polygons and edges. As I said in the previous chapter, you need to select all the polygons and press S and scale it down a little because we shouldn't have a overlap edge with border of the UV. Alright, our UV is ready, and now the model is ready to send it to the Substance Painter. To export the model, you need to select it, go to the File, Export, and we have many file types here. The standard file type between all the 3D tools is FBX. FBX is supported by all 3D models and even game engines. Right, here we have some options. For example, you need to select what you want to export. The selected object, which is the bottle, I already selected, visible objects, or active collection, this collection, all the group. We need to select the selected objects. And then what is the object type? Empty or nothing, camera, lamp or light, armature or skeleton, mesh, other. We need to select mesh. Or we can select all because we just selected the 3D model, and no matter we select a camera or not because we didn't select any camera. Also, we have extra options. For example, you can change the direction of the model, the scale of the model, and so on. But the most important part is the animation. If your model has animation, select this. But if you don't have, just like me, unselect it. Alright, press Export FBX. And now, as you can see, we have a bottle.fbx. Welcome to Blender 4.5 course. In this video, I will cover animation in Blender. Animation actually is any motion in Blender. For instance, adding a movement or rotation motion to this cube, or a complicated animation for a human or creature muscles, or creating a motion graphic in Blender. Everything which has any motion is called animation. And the most important part for the animation is the timeline, the window we have here. If you don't have this window, you can open it in the animation tab and timeline. Actually, right click and close area and open a window by dragging the corner. Alright, here we have a new window and switch to the timeline. Here in the timeline we have some numbers, a number here, a number here, and a number here. What are these numbers? These numbers up here is the frames. Actually 30 frames means 1 second, and in some cases 60 frames are 1 second. This number stands for this line. If we move this line, we can see the number is changing, and this shows the current frame we are placed. Right, this is the start frame. We can set it to 20. Actually the animation will start from frame 20, and this is the end frame, and actually the animation ends at this frame 250. We can play the animation using this button or space key on the keyboard, or play the animation actually reverse, or using the Control Shift and Space keys on the keyboard. And I don't want to explain these buttons because I didn't explain about the keyframes currently. Alright, we can press N to hide this panel. Now let's add a movement to the cube. Want to move the cube, for example, from this point to this point. We can do it in two different ways. But the main concept is specifying the starting point, the starting frame. Actually, you need to specify which one of these numbers are the starting frame of your animation. I want to start from 0. Here we need a concept called keyframe, animation keyframes. And we need to add an keyframe for movement animation on the point we want to add a motion. Here at 0, I want to add a position, a motion, this position. So I can press this button, which is the auto keyframe. It will detect your movement, and if you have any motion, it will add a keyframe for the type of the motion you are using it. For example, if I move the cube, here you can see we have a move keyframe, and if I expand the cube action, as you can see we have a keyframe in the type of object transformation and location. Actually it will insert for the X location, Y, and Z, all of them, because the location is integrated with these 3 axes. Alright, now let's collapse them. And here you can see we have a keyframe, and we can move it by selecting them and moving them anywhere. If you don't want to set them to 0, you can move them, not remove them, and add another keyframe. And if you don't need a keyframe, you can delete it using the delete key on your keyboard. Right, now it's time to move it to here, to this point. And I want to specify the finish step here. Here 60 is good, I guess, and move it here. Alright, as you can see we have another keyframe, and now if I move the time bar As you can see, we have an animation here. Or press space to see animation. If we want another keyframe at this point, we can easily edit and add a motion in the x-axis. Here, let's see, we have this motion. And at this point, I want to move it again along the x-axis. And here we have this result. If you want to rotate the cube, you need to add another keyframe because the current keyframe is useful for position and location changing, not other transformation attributes like rotation, scale, and so on. You can press rotate. We can go to the rotate, press shift space and rotate. And here we can move the cube, but be careful about something. For example, if you don't have a starting point and start from here, for instance, and move the cube, as you can see, we don't have any movement because this is the starting point for the rotation, and we don't want this. I want to start from 0. It's arbitrary, you can start from everywhere you want, but I want to start from 0, and this is not ideal. Let's remove the key, alright, and start from 0. This is the starting point. Actually, I want to start from rotation 0 for 3 axis, and the question is how to apply the starting keyframe, which I want to set all of the rotation values at the start point to 0, not a value, because actually we need a motion to add the keyframe. So we can add a little movement. Here we have the movement. Actually, we can add a little rotation, and here we have a new keyframe for the rotation and set it to 0 again. I still have the rotation keyframe and didn't remove. And here we have the 0 value for the rotation, and here we can change the rotation. And as you can see, we have this result. And for the 60 frame, we can set it to 0 again. We have this result. Alright, now let's focus on the second method to add animations. Let's remove all the keyframes, and here instead of auto keyframe, we can use I key on the keyboard. Using I key, you can add custom or manual keyframes. For example, move your mouse on the attribute you want to add keyframe and press I. And here we have a custom keyframe. And for the next keyframe, we can add another keyframe. And here we have 2 keyframes, and you can easily move your cube. And for the next keyframe, we can change the location of the timeline, and here move the cube. Now press the I key on the location again, and we have the movement. Here we have a complexity in adding motion, but actually everything is manual, and we can prevent from random motions because the auto keyframe can result in adding unexpected motions. But with the manual keyframes, we have more options, and we can add keyframe on any field we want. For instance, let's add another window and go to the shader editor, press N to hide this panel, and here we have this material for the cube. Go to the material view. Alright, I want to change the base color, and I can't use auto keying. Actually, I want to change the base color based on the time. For example, 0 is white and 40 is red, 80 is green, and we can't use auto key. We need to press I. Here for the 0, press I, and actually you can see the yellow effect like this, and this is the keyframe, and move the timeline to 40 and change the color to orange and press I again. And as you can see, the color is changing. And at 80, we have green. As you can see, we have this effect. And actually using the manual keyframes, we can add keyframes anywhere we want. You can add interesting motions with the manual keyframes. For example, you can change the metallic, roughness, and other attributes based on the time. We have a tab called animation, which it gives you more control on the animations. For instance, we have a specific window here. It is a dope sheet, and you can apply more adjustments on the animations. But we have other windows. For example, the most important window is the graph editor. And it's actually complicated, but if you work with it a lot, you can easily adjust the animations and apply many effects you want. Let's explain the structure and the concept of the curves in the animation. As you can see, the green color represents the Y axis, and the other colors, as you can see, it's a constant line because we don't have any motion for the X and Z. Let's expand the window and press N to hide the panel, and here we can change the curve. Here, if we change the curve like this, as you can see, we have a faster acceleration. And if we change it like this, we have this acceleration. It goes back and then goes forward. And actually, this curve works with the value. You need to see the values. Let's see. Move the timeline and see the Y. As you can see, Y is increasing. Actually, the Y value represents the position of the Y curve, and here increasing and then decreasing. You can adjust the curve based on your needs. For instance, if you want a cartoonish motion, you can adjust the curve just like this. As you can see, we have a different motion, and it's good and look like a cartoonish effect, and we can change the endpoint curve and actually change the end point. As you can see, we have a cartoonish movement just by adjusting the curve. In fact, these are the keyframes, but represents in a shape of a curve, and everything in the timeline equals to this view, but in a curve view. And we can delete every keyframe, move the keyframes, and add keyframes using the auto key or I key. Also, we can apply group changes. For example, selecting all the nodes and right click. And here we have many options: mirroring the curve, duplicating the keyframes, deleting the keyframes. Actually, we can use delete key on your keyboard or shift key for duplicating. You know about the I key already. And easing type could change the shape of the curves. For example, ease in means we have a slower initial point and a faster motion for the end point. Ease out is a faster initial point, and ending point is smoother and slower, and so on. Also, you can change the interpolation mode. For instance, constant. As you can see, we don't have any animation, but at the end point, it will go to your desired position. Or you can use linear. We have this structure, no easing out or easing in. Or Bezier is custom option, which we can change the curves, And we have other shapes, circular like this, or quadratic, and so on. Let's set it to Bezier. We have copy option, paste option to copy the keyframes and pasting. For instance, in this point here, press Ctrl C and Ctrl V. And as you can see, we've repeated the animation. And actually we have a paste flipped. Let's see, paste flipped, or press Ctrl Shift and we have this effect. Alright, this is all we have in the basics of the animation in Blender. Actually, you know about the animations right now, and you just need creativity. For instance, with working with the curves and adding beautiful effects, beautiful animations for every object you want. But I will work on the other animations to make you more familiar with this concept. If you want to access to all chapters of the course, you can get it for free from blackcave.com/n/tutorial. Also, you can get access to other courses related to the 3D rendering, 3D modeling, and also game development. You can get access to many tutorials and extra chapters, advanced chapters of this course. Also, at the final, you can get a certificate and add it to your resume. Also, the link is in the description.